Hello, good morning everyone. Let's start our today's session. In our previous session, we have already seen in the different types of the formula according to a correlation coefficient. And our last formula is R is equal to covariance of x comma y divided by sigma x into sigma y. The covariance of x comma y is equal to what? 1 upon n summation ब्रैकेट में x minus x bar into bracket into y minus y bar and divided by sigma x is the standard deviation of x and sigma y is the standard deviation of y where covariance x comma y is equal to see here 1 upon n summation x minus x bar into y minus y bar n is equal to number of x comma y pairs. That means the number of terms x and y. X bar is equal to mean of x is equal to summation x upon small n. Small n that means number of terms. Y bar is equal to mean of y is equal to summation y upon small n number of terms and sigma x is equal to standard deviation of x. Standard deviation of x, the formula is under root summation x minus x bar whole square divided by number of terms. Sigma y is equal to standard deviation of y, that means under root summation y minus y bar whole square divided by number of terms. And here dx is equal to x minus a and dy is equal to y minus b, where a and b are assumed means of x and y respectively. So next is the regression equation. This is very important. Regression equation. What is the regression equation? The algebraic expression of the regression lines are called regression equation. Since there are two regression lines, there are two regression equations. We have two types of regression coefficient and two types of regression equation. Next is the using the method of least square, we have obtained the regression equation of y on x as y is equal to a plus bx and that of x on y as x is equal to a plus by. We have already seen in our introductory session what is the curve fitting of and what is the straight line equation of the straight line y on x or x on y. The values of a and b depends on the means, the standard deviation and coefficient of correlation between the two variables. So these are two equations. These equations are written as follows. If we find regression equation of y on x, first we say y. So the starting of the equation is y. And if we can say x on y, we find the regression equation of x on y, then first we write x. So the regression equation of y on x, the formula is y minus y bar is equal to byx. Here byx is regression coefficient of y on x. Bracket में x minus x bar. And the regression equation x on y, the formula is x minus x bar is equal to bxy. First we write x on y. After that we write the y and the bracket one is y minus y bar, where x bar is equal to mean of x is equal to, that means what, summation x upon n, and y bar is equal to mean of y, that means what, summation y upon n. And the regression coefficient byx, the formula is r into sigma y upon sigma x. Here see here carefully, here we write the y on x, the suffix is yx. So first we write y, after that we write x. So here the x is last one, so in the denominator we write x. Again, bxy is equal to formula is r dot sigma x upon sigma y. Here in the last is the variable is y, so in the denominator we write sigma y. Sigma is equal to standard deviation of x and sigma y is equal to standard deviation of y. Small r is equal to correlation coefficient between x and y. Okay, so there are some formulas of the regression coefficient. The following formula are used for calculation of byx and bxy. That means what? Regression coefficient of y on x and regression coefficient of x on y. When sigma x and sigma y and r are given, in case we are given in the standard deviation of x, standard deviation of y, and given in the correlation coefficient. And for example, we find the all two regression coefficient. So the formula is byx. That means regression coefficient of y on x is equal to what? R multiply sigma y upon sigma x. So second one is bxy. That means regression coefficient of x on y. The formula is r multiply sigma x upon sigma y. In the denominator, we write according to this variable. Got it? When we are given in all these values, that means what? Number of terms, sum of column of x, sum of column of y, sum of column of x square, sum of column of y square, and sum of x into y, the column of x into y are given. In case in these values are given, and we find the two regression coefficient just like byx and dxy. So formula is number of terms and summation xy minus summation x into summation y divided by number of terms summation x square minus summation x whole square, and the regression coefficient of bxy is equal to small and summation xy minus summation x into summation y, and the divided by number of terms small and summation y square minus summation y whole square. So next is the when the deviation are taken from their means, that means x bar and y bar, and x bar and y bar is the actual mean. So the regression coefficient of byx is equal to summation x minus x bar y minus y bar divided by what we write y on x. So x is last variable. So in denominator we write summation x minus x bar whole square. The next regression coefficient is bxy. That means what? In the numerator here same values summation x minus x bar into y minus y bar, and the divided by here we write the y in the last. So summation y minus y bar whole square. Don't be confused. In our correlation coefficient, the denominator we write under root summation x minus x bar whole square. Keep in mind. And in regression coefficient, we write without under root summation x minus x bar whole square and summation y minus y bar whole square. So next is when the deviation are taken from assumed mean, assumed numbers. So we use these two types of formula. This formulas is not mostly we हम लोग इसको ज़्यादा use नहीं करते हैं because of this is very complicated and the solution is very lengthy. Solution बहुत lengthy होता है. Okay, where in this formula where dx is equal to x minus a and dy is equal to y minus b. A and b are any assumed numbers. And the last is when the values of covariance and variance are given. For example, we are given in the covariance and variance. So the regression coefficient b by x is equal to covariance of x comma y divided by sigma x whole square, and bxy is equal to covariance of x comma y divided by sigma y whole square, where x is equal to x minus x bar and y is equal to y minus y bar. So this is the properties of regression coefficient. The properties of regression coefficient, the first property is the geometric mean, that means small r between two regression coefficient is given by, that is small r is equal to under root byx into bxy. Both the regression coefficient will have the same sign. This is very important property according to a regression coefficient. If we have two types of regression coefficient, first is regression coefficient of y on x and second is regression coefficient of x on y. If the values of byx is, for example, positive, so automatically bxy is also get the positive value. If byx is negative value, so bxy is also negative value. In case there are different sign, byx just like byx is positive and bxy is negative, that means this is not valid. Okay, so always both the regression coefficient will have the same sign, that is they are either both positive or both negative. The next property is the values of both byx and bxy individually cannot be more than 1. Got it? byx and bxy दोनों की ही value greater than 1 नहीं होगी. And the last is the sign of r is same as of regression coefficient. That means what? If r less than 0, then byx less than 0 and bxy less than 0. For example, we have the values of bxy is equal to minus 0.35 and byx values is minus 0.75. For example, so bxy and bxy both the sign are negative. दोनों will have the same sign. Both regression coefficient will have the same sign. So if we put all these values in our formula, that means minus 0.75, minus 0.25 and under root. So in our mathematical, these values are we get in the positive sign because of minus into minus equal to plus sign. So we here we get the value of r is positive, but this is the wrong answer. Always we always you keep in mind, if our regression coefficients are same sign, if both are positive, then we write the value of r is positive, and if both are negative, then we write the values of r is negative sign. Got it? So next, the example is the coefficient of correlation r between x and y is defined by r is equal to summation x minus x bar into y minus y bar divided by root summation x minus x bar whole square root summation y minus y bar whole square. This is very important formula. Sometimes we use only this formula and our answer is 100%, we get the correct answer. Or r is equal to covariance x comma y divided by sigma x into sigma y. Here covariance x comma y is equal to 1 upon n summation x minus x bar into y minus y bar, and this formula of the sigma x, that means standard deviation of f is equal to under root summation x minus x bar whole square divided by number of terms, and sigma y is equal to under root summation y minus y bar whole square divided by number of terms. Put all these values in equation number 1. We get the correlation coefficient. The formula is R is equal to summation x minus x bar y minus y bar divided by under root summation x minus x bar whole square under root summation y minus y bar whole square. The next is the line of regression. Here, two line of regression equation. The regression line y on x. The formula is first we write the y. So our formula is y minus y bar is equal to byx in the multiply x minus x bar, and the regression line x on y, that means x minus x bar is equal to bxy bracket mein y minus y bar. This is the two regression lines. Okay, keep in mind, remember the logically, if first we write x, so our formula is starting from x. Got it? First we write y, so our formula is starting from y, and the regression coefficient byx, that means the regression coefficient of y on x. So byx is equal to summation x minus x bar into y minus y bar. Okay, how we find these values in according to a table? Don't be confused. First you hide the summation. Got it? And mark the column x minus x bar. After that y minus y bar. And our next column is what? Multiply up both columns. That means x minus x bar into y minus y bar. After that, you sum whole the column, and the divided by summation x minus x bar whole square. So what is the logic? Logic is that if we find the regression coefficient y on x, that means y on x. So here we write x. In the last variable x. So in the denominator we write summation x minus x bar whole square. Next is regression coefficient Vx on y. That means regression coefficient of x on y. So Vxy is equal to numerator is same. See here, summation x minus x bar y minus y bar divided by what? Here we write the variable of y. So we write summation y minus y bar whole square. So this is our two regression coefficient, formula of two regression coefficient, and this is the formula of two regression lines. And the property is that we have already seen. Property is number 1, the geometric mean, that means R, two regression coefficient is given by R is equal to root byx into bxy. Got it? And the second property is both the regression coefficient will have the same sign. That is, they are either both positive or both negative. And the third property is the sign of R is same as of regression coefficient. If R less than 0, then byx less than 0 and bxy less than 0. Got it? So I will continue this topic in our next session.